So, ladies and gentlemen, I am very happy to introduce the speaker of today's round of our lecture series on sustainability in computer science. The today's speaker is Professor Franz Wotawa from TU Graz. And yeah, you just have heard a minute ago. I know Franz Wotawa from the area of logics, which is today also called symbolic AI, symbolic artificial intelligence. In fact, he grew up in a research unit called databases and artificial intelligence, already starting, so not he started, but the group started in the mid-80s. So there's more to artificial intelligence than ChatGPTs in 3 years. And I'm pointing to this because I've just realized when Franz Wotawa became professor for software engineering at the TU Graz, I knew that his institute had this name. I also know that he is very strong, or there has a lot of people being strong in testing, software testing, and that they use machine learning approaches as a tool for software testing. And now they also show it in their title. So I'm very happy, Franz, to have you from the Institute of Software Engineering and Artificial Intelligence of TU Graz. I'm really looking forward to your presentation, Sustainability in Software Engineering, and without further ado, it's your floor. Thank you.
Yeah, thank you very much for the very nice introduction. Today I'm talking about sustainability in here. I have to say we also have some groups and a lot of projects working on software for sustainability, but you will see that this is not all. But also in software engineering, which means development and later on maintenance and operation, there is sustainability, I would say, an important goal to reach, basically. And today I want to discuss more or less sustainability in software engineering in a very broad sense in here. I used the slide now several years, I have to say, but I extended them, and I also noted some other changes that are necessary because when you look at the current development, and Kathy already mentioned that with ChatGPT and other large language models, there is also a growing interest here in software engineering for using those things in here. I remember the first paper I saw more than 5 years ago, CodeBird, I'm not sure for what it was. Maybe it was testing, maybe it was debugging, maybe debugging, I think, but also other things in here. And today we have Copilot, which is based on Codex, where some recent studies showed that more or less developers in practice use that or write about 50% of the code using such tools. And when we know that LLMs have a not nice, I would say, footprint with respect to energy consumption and of course CO2 emissions in that as well. We see that at least during development, the sustainability may not be that good in, as I said, in terms of CO2 submissions in here. Anyhow, there is a little bit more to that topic, and as I said, I want to give you a more or less an overview of what constitutes sustainability in software engineering, what are influencing factors. I will also present some. It's not latest work. It's I would say quite old these days, but how methods can be used also to improve sustainability of software, and that may be a starting point also of you for thinking about where to go and how to obtain sustainability in here. I will try to keep my presentation 45 minutes so that we have enough time afterwards also for a discussion. So let's have a look where sustainability and here I'm mainly focusing here on the energy consumption of software engineering comes from, and here we have a very simple example and to show where energy consumption may be observed or more energy consumption may be observed. Of course, the energy consumption not only depends on the software that is running on a computer, so therefore, of course, there is also an influence on the hardware. Depending on that, we have that. Anyhow, when you consider programs running, then the energy consumption heavily depends, of course, also on the underlying software. Here we have a very simple example. A function is element. As you can see immediately from the name of this function, it checks whether the content of a variable A is an element of some collection, like a list in here. I'm not doing now anything or stating anything about underlying data structure. Anyhow, it's a collection of elements, and I want to know whether A is element in here or not. Of course, there are many algorithms for that purpose, depending on the internal structure and so on. I now have here only two of them. One is going through the collection, more or less assuming that the collection is an array in here, and it's going through this collection, and then if there is a evidence, so if you find an element where equivalence holds, then we return true, otherwise we return false. Of course, in the big O notation, so in the computational complexity, this means basically that um, uh, yeah, you have always, not always, but on average, it's maybe n when n is the length of A divided by 2. Of course, it depends where you search, but considering that every element has equal probability, it's n divided n half, basically what you have, and in the big O notation, it's n from the computational complexity point of view. In the second implementation, we use a hash function. Basically, the underlying data structure still might be an array, but we have a hash function, which means basically a function that returns the index to us of the certain element. And you all know that maybe in the hash function there are the hash function is never unique, so we may search a little bit longer in here, but which is not covered here completely in this implementation, I have to say. So it would be a little bit more complicated on that. But anyhow, in the ideal case, you can find the element in here, and when assuming maybe that the hash function is unique, with only one trial here, and so we have O1, which means basically that is element, the right version of is element seems to be the better one because can be fast compute. There is, of course, a hidden assumption in here. The hash function computation should not be that complex in here, and especially not depending on the input length in here or the length of the collection. But these are underlying assumptions that usually hold. So the right version would be better. When dealing with other implementations, I have to say, for example, when you want to iterate over a structure, then of course, maybe hash lists or hash structures are not the best one, and maybe linked lists here are better choices. Anyhow, in this case, I think everyone agrees that maybe the right version is better. Anyhow, and this is the second part of this example. Of course, it's not the code you see here that is running on the hardware. For that purpose, basically, we have a compiler, and the compiler is then basically making a program, an assembler program, or of course a meshing code program that runs then on the particular hardware. Here you see the basically examples how this can be implemented in here. And we see unfortunately not the whole program, but in one case we have some iterations. In the other case, there is only this call to the hash function. And in order to test whether one of these implementation is more sustainable in, as I said, in terms of energy consumption, you would run both programs on various examples that are realistic examples, of course, and then you compare the resources. So you would have any measurement, either device or software that gives you this energy consumption. Anyhow, what I already said and stated is that this runtime is different because also of computational complexity. So this is one factor we have to consider. To summarize that, of course, runtime and energy consumption, when we use that as more or less interchanging elements in here, they depend on the number of statement that needs to be executed, so processed in here, which basically also, as a consequence, lead to the statement that we need a proper data structure for the right job, and this matters a lot. And of course, we need to reduce the overall number of statements as well, because each statement usually is then mapped to several different statements in the compiler, and it's more complicated when you have knowledge in compiler construction, because it depends also then on how this compilation is done, whether you need a lot of cycles in the computer, for example, when you have always to fetch elements from the memory, and when it is not assigned basically here to the processor. So anyhow, what we see basically is that runtime energy consumption and also the runtime of the compiled entities, of course, assuming that the compiler is doing optimization here, makes a difference. Anyhow, in order to measure basically whether one program is more sustainable than the other, we need, of course, measurements, either devices or in this case, software. For example, for the Mac, where I'm making the presentation, there is also software that gives you back more or less the at least an estimate for the power consumption of certain tasks when they are executed. The question here is this all in here? Because it's only focusing here on the part where we execute the program, and it would reduces to some extent, at least from my perspective, the view on sustainability only on the case of operation, running a program, running software in maybe a more or less complicated environment and so on. And clearly, this is not all, basically, because sustainable software engineering, we have also the second part before operation, which is development, and I mentioned that already. So we can also improve sustainability with respect to um, the I hope you can still hear me. Um, with respect to the my God, now I lost control. Yeah, development. So what are you using during development? What are the processes there, and so on? So this is basically also something we need to consider. Before going into details, there was a question last time, because I promised that I will also, let's say, more or less do some research on sustainable software engineering. We do it to some extent, I have to say. We also now come up with an initial model for comparing different diagnosis algorithms for checking their energy consumption, where we vary basically the methods machine learning versus logic-based methods and all these things. And we are now on a stage for making a more detailed model about that. But when saying this, this is only one part again of the software engineering cycle and not all. The second thing I've done in the last year was more or less also trying to get information about the status, the knowledge of students with respect to sustainable software engineering. So what is the knowledge of students in this area? And for that purpose, I prepared a questionnaire which I passed to the student in one course, I have to say. That's a course at the master level. So the students are basically, let's say, more mature ones, older ones. Not all of them are officially master students, but they are not in the first year, I would say. There are third year or second year, end of second year, because it was during the summer semester until third year, fourth year students. So they are experienced. A lot of them already work at companies and so on. And I was interested basically whether they know things here about sustainable software engineering. And of course, we would be able to use also this course here to gain further information. But let me show you what students answer to that survey. And one plan is really to make a repetition of this study every year from now, again in the same course, different students, so to see whether this knowledge increase or not. This survey was conducted the last term, summer term, at TU Graz, around 60 students. And here you see the outcome. Most of them are male students, but I think this more or less is, yeah, that what we can expect, unfortunately, at the moment here. As I said, from the age, none of them were younger than 21, which is an indicator, even in the case that they are basically, so you see here the age ranges, even when you may assume that they are not master students officially, they are more mature and maybe almost at the master level, maybe with some, exams left in here. Yeah, so this is what we have here from the statistics of this population, I ask. And then I ask questions like, have you already taken courses dealing with sustainable software engineering in the past? And at least some of them, 8% of that cohort, really were taking courses maybe like this one here. Then I asked the question about, okay, courses, lectures are one part, but maybe it would be interesting because many of them are already working at companies. I asked basically, do they have knowledge about software engineering principles, sustainable software engineering principles when they work as programmers? And here the ratio is a little bit better. Instead of 8%, it's 15% saying yes, they already use some concepts of sustainable software engineering, which is good basically, but still 58, sorry, not 85, 58 do not. And so here we see that there is still a lack of at least usage, maybe a lack of knowledge in here. And what we see here, and so it's good, I would say, to have lectures like this one here, and we may add other lectures here as well in order to increase this awareness of this issue. I then ask also basically other questions. Do you know countermeasures for reducing the overall energy consumption of development? And this was quite interesting. Still, there many people were saying yes for 43 34, sorry, 34% were saying yes, and which is larger than expected. And even in the case that they don't use it, they know at least some countermeasures in here. I checked some of the countermeasures because I also asked then the students about some issues, some ideas about these countermeasures, and they raised some of them, and I checked it, and at least to a good percentage, that was not bad at all, I would say. Of course, I also asked the question about reducing the energy consumption of the programs themselves, which has nothing to do with the development, or nothing to do with the development, is that right? But has not directly to do with the development, but more with the final product, the program that falls out of development. And here more people know that. And I think this is also quite good because many people know now that maybe the data structure, the libraries, and so on, they are using impact basically also the energy consumption, and this is quite well known, which is basically one of the nice good results. I come back to this survey a little bit later, but before that, I want to clarify several things in here in sustainable software engineering. In particular, what I want to do is to answer the following questions in my presentation. Why does sustainability matters for programs? And of course, in particular, software engineering. What is sustainable software engineering? Because there might be different views on that. So I want to clarify also this picture. And then the question of how can we support sustainability in software engineering in particular should also be answered in here, at least partially, I have to say. So there are maybe no details in here in some or the other direction, unfortunately. But for the definition and for giving you an more or less a general picture on that area, I think that's something I can promise you. What's important to note is basically this last item I have here on the slides. The focus here in my presentation is on software engineering, okay? It's not on the use of software to improve sustainability. I think most of the other talks talk about the use of software, how, maybe not all of them, but many, maybe how software can improve sustainability here as well, in order maybe to for a particular purpose, maybe how to make certain software sustainable in some extent using theoretical foundations and definitions and whatever. Here we focus really on software engineering as a discipline and how software engineering can help here to improve sustainability of programs, of general programs, without considering their domain and other aspects in here. Okay. Why is sustainability here in this area important? So first of all, software is becoming more and more important. Okay, so this is, I think everyone here agrees on that. I always use this example from the automotive industry. I have also a lot of projects with the automotive industry, which performs unfortunately not that well at the moment. And when you have a look at that, is that most of the functionality you have in modern cars does not come from the hardware, basically. It's requiring software in here. And when you go to autonomous driving in particular, all here is basically software. Of course, with the exception of the interface between the physical world here and the cyber part of the whole system. So one idea in autonomous driving is basically to have something like a mobile phone, but with wheels. And so all the functionality basically is then implemented using software and not hardware anymore. And I think most of the prediction we had maybe 15 years ago are not right. I think it's going faster, and unfortunately, especially in automotive engineering, the software is even the case that the safety there testing and so on is improving. Still, software development is not the strength, I would say, of the automotive industry, with maybe some exceptions. But usually, unfortunately, this has not considered in a good enough way, unfortunately. But anyhow, software in general, not only focusing on the automotive industry, is basically more and more important. When you have a look at ICT, then, and you heard it, maybe it's now more, but it's somehow between 2 and 4, maybe 5% of the global greenhouse gas emissions. And because software there is the backbone, software is responsible for a huge portion in here. And my educated guess is that this will increase substantially, especially when considering LLMs. The question is whether we find better solutions for that or not, but at least for a certain period of time, I guess there will be a huge impact now because of this advanced software in here. So maybe it's then more than 4%, 5%, maybe 10% of all greenhouse gas emissions that are in here. There are some ideas of reducing that, but yeah, we'll see how that will work. Yeah, as a consequence, of course, when developing software with a lower energy footprint, then we can save greenhouse gas emissions substantially. There is a nice report, and maybe many of my colleagues mentioned that, the Brundtland report, defining sustainable development as the ability to meet the needs of the present without compromising the ability of future generations. I think this is a very nice definition, which basically means that we should not use resources so that they are not longer available in here. And greenhouse gas emissions are one thing in here where the world might not improve, basically. And therefore, we should take actions without any discussion. Okay. What is now sustainable software engineering? There are many definitions around. Even Microsoft, interestingly, has a definition. Basically, it's saying it's an emerging discipline at the intersection of climate science, hardware, software, electricity market, data center designs, and so on. The principles of sustainable software engineering are a core set of competencies needed to define, build, and run sustainable software applications. So it's a very general definition that more or less puts things together, but it states basically that there are competencies needed for defining and building, and then of course running a software application in a sustainable way, where we do not use a lot of resources. There was an article by Alexander Belokrilov, The Power of Sustainable Software, a Forbes article also from 2022, stating that sustainable software engineering, of course, is becoming more popular nowadays. This approach aims, so sustainable software engineering, to design software that will increase overall applications efficiency and reduce energy and space consumption requirements. I think it's not far-reaching enough. Basically, it's more focusing on the software, which usually people always make equivalent to programs, which is not completely true, I have to say, but this is a different story. But it's basically focusing that we need here to develop sustainable software, but maybe not far-reaching enough. There are some other definitions in here which may be more, how to say, more general. One is here stating that sustainable software is software whose development, deployment, and usage result in minimal direct and indirect negative impacts, or even in the best case, positive impacts on the economy, society, human beings, and the environment. We often focus on the environment only, but here it's basically defining that in a very broad sense, like sustainability is always, not only focusing on the environment in here, and also including development, deployment, and usage. Development is clear. People are programming, are testing, are making or obtaining requirements before that, deriving specifications and so on, making documentation. All these can be categorized under this term development. Then there is a deployment. This deployment these days is usually done using networks. Networks use energy and so on. So here is also something that has to do with, or where we may think about sustainability in here, but maybe it's more sustainable than using say ordinary mail where you need to drive data storage from A to B for deployment. So my educated guess here is that the carbon footprint for deployment here is less when we use network technology as we are now using to, I think, 99.999%. Of course, the usage is also in here. So my educated guess is that when we want to save energy, when we want to have no negative effects to the environment, but also economy and so on, then we need to consider mainly development and usage of software. And I think this is very nicely considered in this definition from the people inventing this GreenSoft model, which is a reference model for green and sustainable software and its engineering. That means basically when saying that there is a prerequisite for sustainable software, which is a sustainable software engineering process or a sustainable development process, which has to consider the environmental impact basically in here. And having this, then of course we need also to come up with something that is sustainable during operation, and this is also quite important to know. Operation, of course, these days is often done using data centers, using the cloud. Basically, the cloud infrastructure is maybe also costly. So here the processes might also be quite having a huge impact here on the environment. What are the dimensions now of sustainable software or sustainability in software? There are, of course, many factors, as said before. There is this human sustainability, environmental sustainability, which is usually referred to as green software, and economic sustainability. We mainly focus in this representation on the environmental sustainability, but it's also about humans and economy. Let's go to human sustainability. Of course, all the software we want to develop should help people, should help people making their jobs basically, may also help to gain further knowledge and other things. So when we have here human sustainability and human resources, then of course those things should not have any negative effect on psychological aspects or the group performance and so on. I think this is very well researched to some extent. Yeah, I think it's very well researched, basically considering human-computer interaction and of course labor rights in most of the countries and so on. Economic sustainability here means basically that this product, yeah, we should be able to sell it. Of course, a product that is sustainable means also that it may be good in terms of quality, because when it is good in terms of quality, then we don't need a lot of maintenance. When we don't need a lot of maintenance, we save, of course, energy. This is one thing. And the other thing is that we can reduce costs in here as well, because maintenance costs are very high costs, accounting 40 to 60% of the overall costs of software during the lifetime. And so to be more sustainable in these terms, of course, would mean that we have to improve the quality of software. With the negative effect may be that there is more energy needed when performing the overall development in here. And the last part is then, of course, environmental sustainability. And here, everything that is needed for the development in here should be considered and should be not only considered as a negative effect. Some things are necessary in give you the overall picture, but coming up here with a model might be quite complicated, I would say. Okay, so when having a look about these dimensions, we can come up with a more or less a picture here where we have the different classes that different categories we have when we consider software sustainability. We have here these economic aspects. We already talked about that, the human aspects, and then green software. When we like all the categories, of course, there are many interpretations of that. We mainly focus when we talk about software sustainability on the factor green in software, which means basically the engineering part, and then, of course, also the operational part and governance and other issues that come here with these programs and with the development of software in general. Another part, which is also referred to as green software, is green by software, which might be, for example, coming up with an expert system, with a system where we use machine learning for diagnosing, for example, heating systems, being able to find faults there earlier, and then, of course, save energy on the overall lifetime of this heating system because of pinpointing, let's say, the necessity of maintenance activity as early as possible. In my presentation now, we are not talking about green by software. The focus here is on green in software, and this is basically what we want to tackle in here when we deal with software engineering and with sustainability in software engineering. Hence, in a closer sense, software sustainability is green in software, green software where the in is central in here. So we focus here on the development, maintenance, and operation. Maintenance, and of course, maintenance is necessary in operation, but when a program requires a lot of energy because it's so awfully programmed, then of course it's also not sustainable from the environmental perspective, at least in here. So how to do sustainable software? It's basically a reduction during the development, maybe using less compilation, maybe not using things in here like nightly builds, maybe build only once a week, maybe less. Think about quality from different perspectives, which are less time consuming, and of course use tools that are not requiring a lot of energy, basically, like not using LLMs in here and other issues. This, of course, is a wish, but may not be working in here. Because you can also say that if you're faster in software engineering, then we also require less resources. And as I said, it would be nice to have a very general model where you can, let's say, have a look at the parameters and the influences on that in order to make an overall reduction in the development. Reduction during use, this is also important. So we need to develop programs that are not requiring a lot of energy. So maybe not developing LLMs. It's a joke, but maybe not developing something like that. Anyhow, even for ordinary programs, when you, for example, use the right data structure as indicated before, then you would here minimize greenhouse gas emission here substantially. When we write high quality software, there is also a reduction. Why? Because don't need maintenance a lot. So also during operation, these costs basically can also be saved and so on. So everything in here is there. And of course, there is a connection between these two fields. But even in this case, you always have to consider there is not only one development, but n executions. So especially when you write a program that everyone is using, like Microsoft is doing, then the development can be costly, also in terms of greenhouse gas emissions and so on. But basically, this program is executed thousands of times a second, and there the carbon footprint really matters then. Okay, and usually this software is running for more than 1 year, 2 years, 3 years, which means basically there are expectations that savings in energy consumption and greenhouse gas emission as a consequence are possible. There are many mapping studies and reviews in here, so to give you also this account there on research activities. What we see here, unfortunately, these are not the recent work in here. We should extend that. But it shows that basically there was a very high, I would say, on interest research-wise on sustainable software engineering. Once 2015, 14, 15, basically. So this was in here. It was then declining. It's now going up again. And you will later see there is still a workshop at the ICSI conference also dealing with green software. So there is interest, but the peak may be reached. And this is also maybe not the best we have. So maybe it would be great to have more people working on that. Okay, due to time restrictions, I will go fast through the next slides in order to show you one application. You should have access also then to the slides so you can read most of the content later on. So there is a model, GreenSoft, which basically is a process model that aims at sustainable software product engineering, more or less. But not only the development, but also, of course, after deployment in here. But anyhow, it's mentioning three conditions that sustainable software needs to capture. One is that the software is produced in a sustainable way. The software itself has minimal negative effects on social and environmental things in here, and the software functionality reinforces sustainable development, or at least has no negative impact on society or the environment. So these are called then second order and systemic effects in here. So this is more or less how you can distinguish sustainable software products from non-sustainable ones. The GreenSoft model considers then these four stages. One is, of course, the life cycle of a software product, the sustainability criteria that needs also to be captured. Very much important, the process model that is in here, and of course, some recommendations and tools that someone would use or should use when dealing with sustainable software in general. Okay. And here you see some of these criteria in here. Basically, when it comes to this quality model, you may know that software quality is nothing that is always fixed. It's basically something that people define, and so it was very good in this model also to come up with the GreenSoft model, to come up with a quality model for sustainable software. It's basically capturing indirect related criteria like fit for purpose, reduction, beauty, Common criteria like random efficiency, what I mentioned here as one of these things here. And then there are direct related criteria that have an impact, of course, on sustainability. If the team needs to travel a lot, of course, it might have a high carbon footprint. If you run everything on the cloud, you may also have a higher footprint in here. But of course, quality also comes or is important to consider usability, accessibility, and other things in here. Adaptability is also very much important here because maybe hardware is not working forever. So to adapt software to meet hardware requirements is also something of importance. And then, of course, as a direct other criteria is the energy efficiency of the final product that in here has an impact on what we would say is better in terms of sustainability, software that is better in terms of sustainability or not. There is also a software engineering process. Basically, there are two versions in here. One or less this process-centric software sustainability, where we consider the sustainability in the management process, in the engineering, and also in the qualification process. The details are here in there, but this is more or less what we have in. It can also be added to agile processes in here, where we integrate it into this agile process, where we have more or less sustainability criteria as important things, as one important measure. So we would have a sustainability executive that measures basically the sustainability impact of the development there and make suggestion of how to improve that in here. Okay, so this is more or less the process in a very brief overview only. But the question is, can we do automation for producing sustainable software? And here is a nice solution that was proposed by colleagues. What they called, so it was Mark Harmon and some of his PhDs. It was called genetic improvement, applying genetic programming for improving sustainability. The idea here is to introduce changes that impact basically the energy consumption and use, maybe how genetic programming is working. It comes with a function, and this function should be optimized. And so therefore, the idea is here to introduce changes and measure then the energy consumption of the change program, measure maybe also that in the test cases whether they still fulfill the software, and then have a optimization function that prefers, of course, programs that are still correct, but lead to a smaller carbon footprint or energy consumption in particular. And by using such genetic algorithm, of course, it would be possible to have more energy efficient software constructed automatically. So how it is done, basically, we have a program here, we have test cases here. The program ideally on all test cases passes at the beginning. Then we are applying changes which lead to a program P prime. And we hope that, of course, again, all the tests passes, but having a lower energy consumption than the original program. So this would be the idea behind. How is this done? Basically, there is always a start in here, and then while changing, we try to come to a better situation, and basically this is done via genetic search. The question here is always, what are genes, what are operations? Here is an overview what we have in here as operators in genetic programming. We have a crossover operator that takes basically the chromosomes or the genes and combines two of them, so the genes of two chromosomes. In mutation, we select one gene in here and change that. And basically, genetic programming goes from one population to another via these operators until we have and then of course we have this optimization function. And when we reach the optimum, then we are usually stopping. So this is the idea in here, what we have. And basically in this slide, we summarize that. The fitness function maps a particular chromosome to a fitness value, basically how it is defined. In our case, of course, it has to consider the number of test cases that are still passing, and of course the energy consumption that should be lower. And the overall genetic algorithm is as follows: initialize the population. We select then parts of this population as using the fitness function. We perform crossover, perform mutation, and then ask whether the stop criterion is reached, which means have we already found something in the population that fulfills or improves the fitness function. If not, then we select again things there, so elements from the population, and repeat this process. Either the stop criterion can also be make this iteratively for 10 rounds or whatever. So it's not only the fitness function that is in here. As said, there is this nice work reducing energy consumption using genetic improvement by Bruce, Betke, and Harman. And it's basically explaining how this here can be done. And due to time, I will only go to the most important things. So the fitness function, of course, is the energy consumption, but also the tests, I have to say. The selection is, of course, something where we want to optimize that. And they also used one particular case of mini-SAT, so it's a SAT solver basically, for producing a version that is improved in here. Okay, and this is also quite interesting. So mini-SAT is used in practice, and so they wanted to show that the approach is working for the for a particular program. Crossover is mentioned here. It's basically done randomly. All the genes are intermixed, and mutation they used delete, replace, or copy, basically randomly on the genotype, and then they were adding that to the thinking. What means delete? Basically, it deletes a statement. Replace, it changes the statement. Copy, it copies from some points to the current location. Those are basically functions we can use in here. They carried out the experiments using MiniSat in here and certain applications of SAT solving. SID ensemble approve and measured basically the energy consumption using this Intel Power Gadget API for macOS. The interesting thing is there is also no similar version available in here for not only for Intel CPUs, which may vanish here in this Apple environment, but also for the new processors M1 and so on. There are tools available. What we see here is that there is a substantial improvement of the energy consumption. So there's a huge reduction. Of course, these figures are better than they look, but it's always between, let's say, 4.5 and 25%, depending on the application. So this is an interesting thing here, showing that the question is, of course, can we optimize it only for one set application and use it in another? Because this would be the interesting thing here, because this is really the improvement in here was only for one application, considering that all the tests passes, I have to say. And what we see here is that it was not possible often. It was only possible when we apply genetic improvement for approve and then use it on SID or ensemble, but then the reduction was only minor. So this is the bad thing we have in here. There is also a quite interesting thing which gives evidence that there is a relationship between energy consumption and runtime. I was stating that whether it's always true, but here what you see is more or less always a straight line, more or less with the time in seconds, the runtime and the energy consumption that was needed. And so it's, I would say, more or less obvious that there is that. So everything that improves runtime improves also the energy consumption as an outcome. Okay, to summarize, and sorry for being late in here. First of all, there are other results from our survey. People would say also that the program execution, so the students in particular, has an impact on the energy consumption. They also agree to a large extent that the tools for programming, like compilers, impact the energy consumption. The same for libraries they are using. There's also a strong agreement on that, which I think is true because of this runtime concern. The use of the programming language does not have an influence. People disagree, so they think basically that programming language impacts here also the energy consumption. Interesting thing. I don't know, I have to say, to be for sure in which direction here we can say something. Then there was another one. There is no evidence that the program impacts energy consumption. There was a strong disagreement. So that these are more or less control questions in here, and at least most of the people answered it in the same way. And the same for the process. The software does not, process does not impact. There is also a large disagreement in here, but still some people are uncertain about that. I hope I was convincing you that the development process as well as the runtime has an impact in here, and that we should work on improving basically sustainability in here. There are other questions on that. Agreeing on that sustainable software engineering is an interesting research and teaching topic. That also the sustainable software engineering should be part of a computer science program. Whether it has to be on a separate course or not, that's basically not that well agreed. So at least there is a tendency, but it's not a very strong agreement, I would say. People are sure that this will become more important in the future. And as a control question, almost nobody agrees that this is a niche topic in here. So yeah, we have discussed and defined the term sustainable software engineering, green software in all the facets. I wanted to show you some influencing factors. I hope I was successful on that, and give you one example from literature, from scientific literature, showing that at least some tools can partially improve programs to be more energy efficient. But I think this is only a first step in one direction. And we presented also the outcome of a study carried out during a lecture at my home university. Other conclusions, of course, there are many different interpretations what sustainable software engineering means. It's not only the environmental aspects. Finding better programs is valuable, leading to green software. I hope you can agree on that. And AI not only negatively impacts, I would say, green software, but may also have a positive impact on that. Maybe LLMs can help also to come up with better, more sustainable software. If you're interested in research here, there is this international workshop. It was last year as part of the ICSI conference, which is the main conference in software engineering, the most important one. Hopefully it's next year as well in there. I don't know, I haven't checked, but you can check as well. And I'm now done, ready for questions.
Thank you very much. As always, very interesting and enlightening, especially this workshop. Is it just a talk? Was it the first time this workshop this year?
No, you mean the
The,
service?
no, not the workshop on green and sustainable software as part
No,
of ICSE.
no, no, it's the ninth international.
Yeah, yes, it's
Yeah,
Zurich.
here
I
you
should
see it. So
read, yeah.
it's
In
quite
nine. Yeah.
it's quite old. There was it was quite interesting because between 2018 and 23
Yeah.
there was no workshop. So it's maybe this is the interesting part here. So oh, sorry. You see here that there was a
I think
not so much
got
interest,
it.
but
Yeah,
it's
yeah.
now gaining
Inter-
again.
which I can imagine. Okay, now interesting. Perhaps you had it last year, and I don't remember. Um, yeah, if there are questions, please
As I saw in the meeting chat one question about
can you repeat for which percentage the maintenance
yeah,
accounts?
so in software development, of course, there are many figures around. Um, and this varies because also of the lifetime of software. So when the lifetime is longer, then of course maintenance costs are higher. So what you find from different studies, older ones, so 20 years ago or something, it was always between, I would say, 50 and 80%, maybe 40 and 80%. It depends on the study in here. My educated guess is that half of the money when you have a program running for a longer time is maintenance, basically.
Perhaps just a remark. Of course, the maintenance costs and was probably also the energy consumption increases, but perhaps on the whole is not still cheaper than throwing everything away and
Of course. No, no, no. I think also,
starting from scratch.
yeah, no, you're completely right, Getty. No, but having the maintenance cost, I think that was more or less studies before we consider sustainability. It was
Yeah,
the costs only. And when you make a fault in software that is running where no developers are available, it's quite costly to
yeah.
repair the software afterwards. This is the problem, the main problem here.
What I like about this lecture series, and especially also your presentation, I think it's mainly about awareness building. At the beginning, you had something about that there is no knowledge. I think in Bay Area, you had. I think it was even one question you asked the students. No knowledge about sustainable software, and I think the main problem is here really that there is no awareness. And in fact, our responsibility as teachers is really awareness building. That's always when we teach to show that there is an impact, that there is a relevance to what we teach, and especially to this for this subject also. If there are no further questions, Franz, it means that you have been, as always, crisp, clear. Thank you very much. Thank you already for the slides. I already forwarded them, so
Right?
you are ahead of time.
Oh, okay. Okay.
Thank you to the audience for attending this lecture, and yeah, see you all next Monday. So thank you very much. Goodbye.
Thank you. Goodbye.
Bye.